Last time we started section P6 Rational Expressions, and we had gotten about halfway done, and we are at this particular one, I believe, number 8, where it asks us to convert this into an equivalent expression where the denominator is 16 minus 2x instead of 8x minus 8. So what we want to notice is what's different in those two denominators. So as you're taking a look at that and you're comparing pieces, you might notice that the order is different, right? I have x at the beginning on our denominator, and what they want me to turn it into, x is at the end. And the reason is because they've switched the sign. So I need to switch the signs. That's something that's going to happen. What else do you might notice is different? How does my 8 compare to my 16? It's times 2. So as I'm taking a look at this particular denominator, I need to take what's here, and I need to multiply it by a negative so that my order will switch on my signs, and by a 2 so that I also get all of the factors multiplied, or the, not factors, but the terms multiplied by 2. And anything I do to the denominator, I have to do to the numerator, so we'll do that on top as well. So as I'm switching this, I now have negative 2x and negative 4 on top, and I have negative 2x and positive 16 on bottom. I would be okay if you left it like this. If you want to rewrite it so that it's in the same order as the denominator they gave you that you wanted to change it to, that would be fine as well. So you have negative 2x minus 4 over 16 minus 2x in the denominator. And that's all they're asking you to do on that particular problem. And the reason is because that's leading into how we add and subtract fractions. So in order to add and subtract fractions when we did them with just numbers, we recognize the fact that the denominators needed to be the same. The same is true when we do it with expressions, not just numbers. So when I've got variables involved, I also need to have denominators that match. So right now on number 9, the first one doesn't even have a denominator, at least not the way it's written right now. But I could rewrite it so that it's written over the number 1. That doesn't change its value. And now it has a visible denominator. So just like over here in getting my denominators to match, I choose what to multiply the denominator by, I do it over here as well. I want my denominators to match. So that first denominator I can change to being what is written already as the second denominator by simply multiplying it by the number c. And if I do that on the bottom, I have to do that on the top. So my initial value that I now have, or my subsequent value I now have on top, is negative c over the c. And then I have minus the 3 over the c. That's what it changes to. If you don't want to actually write that step out, that's okay, because you could just combine the numerators at that point, because the denominators do match. So now this is negative c minus 3 over c. Now I know we can't combine anything really, like in the sense that it collapses, combine like terms. There's no like terms to combine, but it is written as a single fraction now, which is our goal, right? Our goal is to write it as a single fraction. Now on number 10, it's more complicated, right? I mean, I don't really want to just multiply this first denominator by the second denominator. That's a lot. I'd have a lot of pieces to multiply out, and the same thing for the second denominator to be multiplied by the first. So what we want to do to start with and see if that's even going to be necessary is to see what happens when we factor those individual denominators, which is what we were doing with multiplication and division earlier in this lesson when we left off last time. So these are nice enough to do with trial and error, at least the two here are, because the coefficient at the beginning of the x squareds are 1. So as I look at these with trial and error, x squared will give me an x and an x here. The fact that it's a negative 6 at the back means my signs need to not match. I need a negative and a positive. And then I need two numbers that multiply to 6 and add to 1. What's that going to be? Yeah, it's going to be negative 2 and positive 3. So this is the correct factorization of that particular denominator, and if you weren't sure, you could multiply it back out to confirm that you have it done correctly. We can do the same thing on the second denominator. Again, it's fairly nice to do it with trial and error because it's x squared with a coefficient of 1 at the beginning. This one's actually even nicer than the previous one. This positive at the end, again, means that the signs have to match, right? Negative times a negative or a positive times a positive. The positive in the middle means they have to both be positive. So I've got the signs both positive. And then I need two numbers that multiply to 3, and there's actually only two options. I mean, we don't have option, right? I mean, it has to be 3 and 1. That's the only things that are going to work. And lo and behold, 3 and 1 actually will add to the 4 in the middle. So we have a 3 and we have a 1. So what we're doing now is we're comparing, much like we did on this previous problem, we're comparing the denominators that exist, or what we want them to be, and we notice on these two denominators that they both have an x plus 3 in them, right? That part already matches, so that's good. There's only one piece that doesn't, namely the x minus 2 for the first one doesn't match the x plus 1 on the second one. So in order to get them to match, we actually just multiply those by each other. So the first one needs to be multiplied by x plus 1. And if I do that on bottom, I have to do it on top. Hang on, sorry. There we go. And the second one is missing an x minus 2. So if I do that on bottom, I have to do that on top. Now you want to remember these are factors on top that I'm going to distribute through. I do not actually multiply the denominator out. I leave them in their little factored pieces. So that's good news, because that'd be messy for us to have to multiply it out. So our denominator will stay with those 3 factors as the common denominator: x plus 1, x minus 2, and x plus 3. In the meantime, I need to distribute and multiply out everything in the numerator. So if I have x plus 1 times x minus 1, I'm going to get x squared minus x plus x and minus 1. That's what I get when I distribute or FOIL that one out. And then I have this negative sign, so I want to be careful. I'm going to put the subtraction sign and I put a parenthesis. And now I'm going to multiply these two out. So I have x times x is x squared. X times negative 2 is negative 2x. I've got another negative 2x and a positive 4. I do need to distribute. I guess I could move that up just a little bit so it's not quite so low. I do need to distribute this negative through here. And then some of these pieces are going to combine very nicely, right? So this positive and negative x, those add to 0. So as I'm sort of combining the pieces, I now have an x squared. I have a minus 1. And then I have minus the x squared. These two right here are negative 4x. So I've got this negative distributing through, so I have now a positive 4x. And then I have the negative multiplied by the 4 at the end. Same denominator, we're just going to rewrite. There's a few more pieces that are going to clean up. I have an x squared here and a negative x squared here, so those are going to add to 0, right? And then there's a 4x on top that's, by itself. Then I have a negative 1 and a negative 4, so that's negative 5. So on top, I have 4x, I have negative 5, and then in the denominator I have those same 3 pieces I've had along the way: x plus 1, x minus 2, and x plus 3. Now, if I had the ability to factor the top so that it canceled with something in the bottom, I would do that. But 4x and 5 don't have anything in common, so I can't factor the top to allow it to clean up anyway with bottom. So at this point, I am finished with that particular addition and or subtraction problem. Subtraction, this one was subtraction. Any questions? It's kind of a long one. Yes, Allie.
On the top, when you first started the problem, we got from the x2 minus x plus x minus 1. Was that from you doing the FOIL method when you multiplied the x plus 1?
Yeah, I think you're asking me this piece. Well, I didn't mean to do that.
Yeah.
I was trying to do a highlighter. Let's try that again. this piece turned into this piece? Yeah. So foiling or distributing, whatever method is you like to do to multiply that out, yes. I'm getting those two pieces by multiplying it out, and the same thing happens over here when I multiply these two out to give me that one right there. Yeah. Okay, any other questions on that one? Aaron?
How did negative 4x turn into positive 4x?
Which negative 4x? This one?
Yeah.
There's a negative out here in front. That negative has to be distributed through. So I like to do it separately at the end here so that I don't forget it along the way. So in theory, you could distribute it out while you're doing this multiplication, but I think that's a lot of things to keep up with all at the same time. So I usually do it separately at the end. Yep. Anything else? Okay, we have a couple more things in this section to take a look at. I don't know what I just did. There we go. So these are called complex fractions. It's not complex in the sense that it means complicated, although I do think it is complicated. Yes, ma'am?
So you skipped 11.
Did I skip one? Oh, it's not even in here. So let me put it right here. Okay, that's fine. Let me write, I guess I just don't have one of my slides posted in there. I'm so sorry. Let's make it not a bright white background. Okay. All right, let me write number 11. Number 11 is also a complex fraction. It's just not quite as complicated. The directions, I believe, say simplify. Does that look right on yours? And it has 9a over 35 all over 6 over 25a. Yeah?
Yeah.
Excellent. Okay, so 9a over 35, 6 over 25a. So anytime you have a fraction inside of a fraction, which happens here and it happens on the other one over here, you have what are called complex fractions. So they're fractions inside of fractions. Now, on this one, it's not near as bad as the other one we're going to take a look at. And the reason is because it is, in fact, a single fraction on top and a single fraction on bottom, right? So if we're taking a look over here at this one and comparing it, I actually have addition and subtraction of lots of pieces on top and pieces on bottom. So as we're taking a look at this one, if you have a fraction inside of a fraction, the easiest thing to remember is that this is actually the same as if it were being written as 9a over 35 divided by 6 over 25a. And we saw this happen when we worked with rational numbers just individually. And what we saw is that when we have fractions divided by fractions, we can flip the second fraction and make it multiplication. Does that sound like something we remember talking about recently? Good. So we can change this over here to be 9a over 35, and then the division will be multiplication, and we can flip our fraction to be 25a over 6. This actually turns the problem into a problem that's very much like what we did early part of this particular lesson in P6. We have multiplication of fractions. So we can look along the diagonals and we can see if any of the terms cancel out. So in particular, from the top 9a compared to the 6, what do they both divide by? They both divide by 3. So I can do that. I can say, okay, well 9 divided by 3 is 3, and 6 divided by 3 is 2, so I can mark those down there. You can do the same thing on the other diagonal. I have the 35 and I have the 25a. What will those both divide by? 5, right. So 35 divided by 5 is 7, 25 divided by 5 is 5. So those are my individual pieces that I have. And then if I multiply, I can actually look at the individual fractions here too. They don't have anything here, but they could, right? I've got a 3a and I've got a 7. Those don't divide by anything in common. I have a 5a and a 2. Those don't divide by anything in common. So once I've looked for common factors, either individually within fractions or across those diagonals, I can multiply across the top and multiply across the bottom. So that gives me a 15a squared on top, because there's a times a. And then I've got a 14 on bottom. Okay? Good deal. The other one's a little bit more challenging because of the addition and subtraction. I can't just turn it into writing it as division and flip anything because I don't have a single fraction to be able to flip. I've got a mess. That's really what I have a mess. So what do I do? Well, what we can actually do is we can eliminate all the little fractions that are involved to begin with, and that's the method that I like to do. You can also get common denominators, which is another possibility. But I think that eliminating with the fractions that are involved is their simpler option. So you'll notice that these are both y plus 2 in the little denominators, right? Not the big but the little denominators of each individual piece. So what we can do is we can actually multiply by y plus 2 on top and y plus 2 on bottom. Now, if I'm multiplying the entire numerator by y plus 2, it means the y plus 2 gets multiplied by y and by this fraction, both. It also means the same thing down here, by the y at the beginning and by this fraction, both. Now, I'm going to rewrite this and show it a little bit differently because I think it's a little bit easier if I write it differently. But this is what we're doing. We're going to multiply the top by y plus 2 and the bottom by y plus 2. Now, what that actually means is that we're going to multiply each individual piece by y plus 2. So I'm multiplying the first y by y plus 2, so that's going to give me y squared plus 2y. Here, it actually cancels out the y plus 2, right? That's the reason I'm doing it, is because I don't really want the little denominators inside of the fraction to begin with. Now, there's still a negative right here, and I've got that y plus 6. Aaron, it's kind of like that last one that we did, where that negative is still applying to everything in this numerator. Okay, and then over here I still have, oh, I'm sorry, I left one off. This is 2y. Make sure and stop me if you see me make a mistake. And then over here again I have a y squared plus 2y. Please don't think you can go canceling those out. We talked about that last time. You can't cancel individual terms. You can only cancel factors. This y plus 2 cancels, so it leaves me with a negative, and then the 4y plus 15. So it looks like that.
So I'm a bit confused. So the black y plus 2, how did that get there?
I picked it. I made a decision that said I don't want little denominators, and the little denominator that I have is y plus 2.
Okay.
So if I multiply by it, I will eliminate it.
Okay.
The reason I'm allowed to do that is because this is a fraction, and anything you do to the top and the bottom at the same time is equivalent to multiplying with a number 1, which doesn't change things. So anytime dealing with a fraction, as long as I do the same thing to the top and the bottom, it's an allowable operation. And I want to multiply by the y plus 2 because if you'll notice, all the pieces that are now in the white type that I have right there don't have little denominators anymore. So that's why I picked it, was because I don't want it to be present anymore. Erin?
So I guess my question would be, I understand where you did the y plus 2
Mhm.
and then times that first part.
Yep.
And I even understand how it cancels out the bottom part of y plus 6. But why is nothing happening to y plus 6?
Okay, so what I'm doing is I'm multiplying y plus 6 over y plus 2 times y plus 2. But multiplying it by y plus 2 is the same thing as multiplying it by y plus 2 over 1. So just like over here, when I looked along my diagonals and I said, hey, look, there's a 9 and a 6 and I can cancel out the 3, I'm saying, hey, look, there's a y plus 2 and a y plus 2 that can be canceled. And I now have y plus 6, but I have it over 1, and y plus 6 over 1 is y plus 6. So anytime I multiply, I mean, basically what we're saying is y plus 6 here is divided by y plus 2. So if I divide by y plus 2 and I multiply by y plus 2, multiplying and dividing by the same value gets me back to where I started. This is divided by y plus 2. This is multiplying by y plus 2, so I'm canceling out the multiplication and division steps. Okay. We have a little bit more cleanup down here to do. So I have, let's see, y squared plus 2y. I'm going to distribute my negative through, so I have negative y and negative 6. And then I have y squared plus 2y. And then I have negative 4y and negative 15. So I need to combine like pieces, like terms, and see if there's any way to simplify any further. So here's y squared plus y minus 6 on top, and then y squared minus 2y minus 15 on bottom. Are those pieces okay? Okay. It's possible we're done. How do we know? Well, the reason we don't know right now is because it's actually all written out like longhand, right? It's all got additions and subtractions in between them. So in order to decide if we're actually done, we need to factor it and see if anything cancels. Okay? It's kind of like over here. 15a squared over 14 might be done, but if 15 and 14 had anything in common, it wouldn't be finished, right? We would reduce it. So our question over here is whether or not it's still reducible. And the only way we'll know is if we factor it. So we're going to take this piece and we're going to factor it. I'm just going to shift it up so that I have some more space to work. So on the top, if I try and factor, it's again very nice because I have a coefficient of 1 in front of the y squared. My signs need to not match because I have a negative 6 at the end, so I have one positive and one negative. I need two numbers that multiply to 6 and add to 1. 3 and negative 2. I'll do the same thing on the denominator. Again, it's fairly nice because it's got a coefficient in front of the y squared as 1. My signs again don't match, so I have a negative and a positive. I need two numbers that multiply to 15 and add to 2. So I need 5 and 3, and I have negative 5 and positive 3. Does anything reduce? Yeah, the y plus 3's match, so they cancel. So my final answer, man, I am all over the screen. I'm so sorry. My final answer then is y minus 2 on top and y minus 5 on bottom. And those don't reduce because they don't both divide by the same things. I know there's y's that match, but those are not multiplication factors of y's. They're addition or subtraction factors of y's. Any questions on that one? It's a lot. Yep. Caleb.
2y squared on like the first one or whatever.
I did not. That should not have a squared. Thank you.
It's just confusing.
My bad. Yep, that should just be a 2y. You're right. Excellent.